record our session. So guys, every Tuesday I'm going to share the screen through Blackboard Collaborate, so you can always watch it, whatever reason you can't make it. Awesome, good. Antonio, you can hear me? Excellent, great. And so what I'll do here, guys, so what I'm going to do today, y'all, I'm going to go through 2.3, and it's actually not a really long section at all. So it shouldn't take us more than, oops, something happened there. Let's see. I kicked something over here. There we go. Okay, better. So once I'm done with this section here, y'all, we'll use the rest of the class time to answer any questions you guys might have at homework or anything like that, okay? So let's see. 2.3 talks about functions. And so what we're going to do here, y'all, is we're going to see if we can't figure out some of these topics, okay, on functions. And let me do this. There we go. Let's see. Okay. So the first part here says relations and functions. It just says a relation is a set of ordered pairs. So any kind of like pairs of points, okay? And then a function, it's a special type of relation for which each distinct value of the first component, which are what we call the x values, there's going to be exactly one y value, okay? And then the domain refers to the x values, y'all, and then the range refers to the y values. So the easiest way I can explain this has been what I found is the easiest way. I'm actually going to skip, I'm going to come back and do the first two problems, but I'm going to do this problem here, okay? So the domain is always the first set, and the range is always the second set. And the question that we're being asked to find is the relation a function, okay? In order for it to be a function, everybody in the domain can only have one partner in the range, okay? So think about it like this. Think about these as relationships. Boyfriends, girlfriends, husbands, wives, all that kind of fun stuff, right? Everybody here has to be faithful. They cannot cheat. Let me ask you a question. Does 2 cheat? 2 only hooks up with the number 1, right? Okay, so far we're good. What about 5? Is 5 cheating? No, right? Now don't worry about the number 1. We're talking about these folks right now. These people here have to be faithful, okay? What about 11? Is 11 cheating? Anybody know? No, right? What about 17? 17 cheat? Nope. What about 3? Does 3 cheat? No. This here, y'all, is a function. Oops. Okay, now you might say, well, what about all these people? There's a bunch of cheaters here. It does, in order for it to be a function, that part is not all that important right now. Later on, we're going to talk about these things called one-to-one functions, and then the people in the range have to be faithful too. But in order for it to be a function, everybody in the first set can only hook up with one person over here, okay? They can't be hooking up with more than one person. So then what I say is, look, if I come back over here and I look at the first problem, which we hadn't done yet, okay? And I'm going to do the same kind of thing. I'm going to set up 2 circles. And this one here is going to be the domain, and this one here is going to be the range. Now remember, we said the domain were the x values. So I'm going to write those x values in. Now if they repeat, I don't have to put them more than once. I just got to make sure that I have them. So the x values that we have are 1 and 0 and 2. And then the range are going to be the y values, okay? So I'm going to come back over here and I'm going to write each of these numbers down over here. So I have 1, I have -1, we have 0, we have 4, and we have -4. And then we're going to do the same thing. We're going to play that game. Okay, so I'm going to draw little arrows okay? Now, what does this mean? It means that 1 hooks up with 1. What does this mean? It means 1 hooks up with -1, 0 hooks up with 0, 2 hooks up with 4, 2 hooks up with -4. So now, if we're going to ask ourselves, is this thing here a function? Then what we have to do is we have to say, are these people here being faithful? No. We got some cheaters there, right? So then we're going to say here, this is not a function, right? And that's all you got to think. That's the easiest way to think about it, right? Now you might say, okay, well, is there a way that I can do that without having to draw the circles? Of course there is. I do the circles because it's visual, you can see it, it makes sense, right? But if you don't want to draw the circles, like if I look at the next problem here, the way I'm going to be able to tell whether or not this is a function, I'm going to look at my values here, okay? Now remember, the people that have to be faithful are the people in the domain, which are the x values, which are the first numbers in my points, okay? So when I look at the first numbers in my points, do any of those numbers repeat? Yeah. The one that repeats is 3. And not only does it repeat, but the y values are different. If the y values were the same, it really wouldn't matter. But the fact that the y values are different tells me that 3 is hooking up with 7, and then 3 also hooks up with 9, right? I'm just going to drop you off the blue. Don't worry, I'm going home. And then instead of going home, I miss you, right? So we're going to say here, oops, this here again is not, oh, come on, a function, right? It's not a function because the domain values are cheating, right? Oops, I keep hitting that thing. Sorry guys, let me see. I think it's this one here. There we go. All right, let me move myself this way so I don't hit it. All right, so now let me go ahead and keep scrolling down. We've already done this one here. Okay, this one, it's kind of already set up for us in that same kind of like the 2 circles. So all I'm going to do here is I'm going to say, look, 0 only hooks up with 0, -1 only hooks up with +1, -2 only hooks up with +2. So everybody in the domain is being faithful. This here is going to be a function, right? And that's all that I have to do. I just have to look at those x values and make sure that those x values aren't cheating. And as long as the x values aren't cheating, then we're going to be good, okay? So far, anybody got any questions? Am I making sense? Right? We're doing good so far? Okay, just checking, y'all. So now, let me keep scrolling down. Okay, so now, what happens if I don't have points, but instead of points, we have a graph? So there's something called the vertical line test. What the vertical line test says, vertical lines, guys, go up and down, okay? So a vertical line says if you draw a vertical line, if that vertical line hits the graph more than 1 time, then we don't have a function. If it hits it once, we're good. But if it hits it 1, 2, then we're not okay. So what I'm going to do here is I'm going to draw a vertical line. I only hit the graph once, right? Okay, let me draw another vertical line. Every time I do a vertical line, I'm only going to hit the graph 1 time, right? No matter how many vertical lines I draw, but every single vertical line will only hit the graph once. This here happens to be a function, okay? And then if I take a look at the second one down here, and I say, look, let's draw a vertical line. Oh no. We hit that graph twice. And you might say, well, what happens if I draw this vertical line? I know is a little bit off, but if I hit that one, I only hit it once. It doesn't really matter, because as long as we can find one line that messes it up, then we're going to say it's not a function, okay? That's what the vertical line test tells me. Draw a vertical line. You hit your graph 1 time, you're good. If the graph hits it more than once, it's not a function, all right? All right. And we got one more. What do you guys think? Is this going to be a function? How many times did I hit my graph right here? Just once, right? And yeah, just once. And no matter, even though the graph is a little narrow, every time I draw it, I'm only going to hit it once. So yeah, that's a function, right? So the vertical line test, a lot of people like it because all you got to do is draw a line. Pretty easy breezy cover goal to figure out, right? All right. Okay. So now the next thing we're going to do here, y'all, we're going to talk about what we call evaluating functions. Okay. So I think for our problem, I'm just going to kind of scroll real quick. Yeah, we're only using the function f. I did give you guys a function g, but we actually don't use it in this problem. So I'm just going to kind of do this because it's not really important for the problem that I have here. So what we're doing here, y'all, is when we're evaluating functions, this says, let's look at this piece. Oops. Sometimes my pen goes out. Let's look at this piece right here. Okay, f of x equals -3, x plus 4. And we're going to find f of 0. These problems here, y'all, are what I call plug and chug. If you notice, the only difference between this piece right here and this piece right here is that here we have an x. What do we have here? We got a 0, right? So all we're going to do is rewrite the problem, but plugging in the number 0. This is what I call plug and chug. We're plugging in the number 0, and now we're going to chug along. First question, anybody know what's -3 times 0? 0. What's 0 plus 4? There you go. You got it. It's just plug and chug. Every single time, all I'm going to do, guys, plug and chug. Okay. Let's try the next one. Look, f of 1/3. So again, I'm going to come back, I'm going to stare and compare and say, look, what do I have here? I have f of x. What do I have here? I have a 1/3. That means everywhere I have the letter x, I'm going to plug in the number 1/3. So the first thing I have is -3. Now, guys, because I'm plugging in a fraction, I'm going to write that -3 as -3 over 1, right? Now we're plugging in the number 1/3 plus 4. All right. So we're just going to go, remember how we multiply fractions? We just go straight across. What's -3 times 1? -3. What's 1 times 3? Okay. Plus 4. All right. Anybody know what's a -3 divided by a +3? -1. And -1 plus 4? +3, right? If I owed you $1 and I had 4 and I ran into you, you'd say you stole me 3. All right. So let's take a look at the next one here. And guys, all I'm doing is I'm doing a little stare and compare. Look, this is f of x. This part says f of p. So I'm going to come back over here, and everywhere I used to have an x, I'm going to write the letter p. Now, I can't really do anything here, and so that's where I stop. And again, all I'm doing, y'all, plug and chug, right? Take the number, plug it in, chug along, and you're done. Okay. All right, so we got a couple more, so let's try them. Let's take a look at this one here. All right. So if you notice down here, y'all, I got f of a -x. So right here, instead of writing an x, I'm going to put a -x. Come on, pen. All right. So I'm going to write -3. Now we're plugging in a -x plus 4. Okay. So let's see, -3 times -x is a +3x plus 4, and we're good. Okay. All right, and then we got one last one. So notice what we're plugging in now. Now we're plugging in an x plus 2, right? So I'm going to go like this. And we still have a -3, so I'm putting that -3. But instead of me writing an x, I'm writing an x plus 2 plus 4, right? So again, all I'm really doing here, y'all, is taking this piece here and plugging in what we got right there, right? All right, so let me just zoom in so y'all can see a little bit better. All right, so let's go ahead and multiply. -3 times x is a -3x. Anybody know what -3 times 2 is? -6, good. Plus 4. So this is -3x. What about a -6 and a +4? I owe you $6 and I only have 4. -2. -2. Come on, there you go. And so here is our f of x plus 2. Boom. And we got it. Take it away. All right. So let's do the same thing here. We're still evaluating functions. The only part here that's different, y'all, is the way the function is written. In the couple of problems that we just did right now, or that one problem that we did right now where we had to find f of, we had like 5 different values, we're doing the same thing here. But for the first part, the function is given to me as a set of ordered pairs, okay? So if I'm going to do the first part, if I'm going to find f of 2 from here, what it is, what I'm looking for is I'm asking myself, what is the y value when x is equal to 2? So remember, x is always going to be the first numbers, right? So I'm going to come back over here and I'm going to say, look, there's my ordered pair. Now, my points are always written like this, x and y. So I'm asking myself, what's the y value when x is 2? What is the y value here? Anybody know? 2, right? It's also 2. Oops. It's also 2, right? Okay, now we're going to do the same thing for f of -1. Okay? But what I'm asking myself now is, what's the y value when x equals -1? So I'm going to come back over here, and I'm going to look at this point. Well, when x is -1, what's the y value? There you go. +3. And that's all I'm trying to do. Okay. So far, so good? Okay. So guys, let's do the same thing for the next one, right? So we're going to do the same problem here for this problem, and this problem over here. So now what I'm going to do is, for this part here, f of 2. So what I'm doing is I'm looking at my 2. Who does 2 hook up with? 15, right? Okay. Now let's do the same thing over here. All right, -1. Who does -1 hook up with? There you go. There we got it. Okay.
Mr. Rodriguez.
I'm still finding the same values, f of 2 and f of -1. And what I'm going to do is I'm going to zoom in here. Okay. So we're going to find f of 2. Okay. Remember what we said this means? This means, what is the y value when x is equal to 2? So here's my x-axis. I'm going to cruise along. I'm going to do this in red so you guys can see a little bit better. I'm going to cruise along my x-axis until x is equal to 2. Here's x equals 2. If I want to hit my graph, do I have to go up or down? Up. When we go up, what do you think this y value would be? There you go. That's all you're doing. Right? Okay, and then we got one more to do, which was f of -1. Okay, so I'm going to do the same thing, guys. I'm going to cruise over here. Let me erase some of this mess so you guys can see what it is I'm doing. All right, so I'm starting over here. Remember, I'm going to stop until x equals -1. So here's -2. Here's -1. If I want to hit my graph, do I need to move up or do I need to move down? We're going to move down. Okay. And I hit my graph. what do you think this value would be here? So look, if this is 0, this is -1, that's -2, and this one here is, and you got it. And all you're doing is looking at the picture, right? All you got to know how to do is read the picture. All right. Alrighty, so now let's see, we got a little bit more to do. Okay, so here's the next one. It says, let's use the graph of y equals f of x to find each function value. Okay, so just like we did before, we're going to do the same thing here. We got 4 parts to do because we got parts A, B, C, D, and A, B, C, and D. All right, so first thing we're going to find is we're going to find f of -2. Again, just so you remember what this means. This means find y when x equals -2. Okay, so I'm going to start cruising along over here. Okay, here's x equals -2. Notice the graph is already right there, so we don't have to move up and we don't have to move down. What's the y value right there in the middle? 0. Very good. Excellent. Okay. Now let's do the same thing for this one. Let's find f of 0. Okay. So remember what I'm going to do. I'm going to start cruising along over here. I'm going to hit 0. And then do I have to move up or down to hit my graph? You got to move up. What y value did we get? There you go. And I could have stayed home tonight. Y'all already know what to do. And let's try f of 1. Okay. So f of 1, I'm going to start cruising over here. And if I want to hit my graph, I got to move up. And we're going to move up to 2. There you go. And then we got one more to do, f of 4. Okay, f of 4. So we're going to start cruising along this way. And then we're going to move up. We're going to hit that point. And we're going to say that is also 4. And we were able to find each of those values, right? And I'm going to say that was all of 2.3. So guys, I sent you guys an email this morning, and I sent you another message on Pronto today as well, saying, hey, what I wanted to do today was I wanted to go over section 2.3. We just did. The homework problems you guys are going to see in 2.3 are going to be just problems like these, okay? The idea is when I made my notes, I made them based on what your homework looks like. So let me ask you guys on a scale of 1 to 10, 1 being like this is really hard and 10 being this was easy breezy covered well. How did you guys feel about 2.3? Seems okay so far? Awesome. So what I'm hoping for, guys, is that next week, or like between now and say next Tuesday, once you get your homework done for 2.3, that you're like, oh yeah, that wasn't that big of a deal. What I wanted to do the rest of the night was I wanted to answer any questions you guys had out of 2.1 and 2.2. So let me ask you a question. Anybody got any questions out of 2.1? If you do, raise your hand, let me know. Guys, so right now it is 6:23, so it took us 23 minutes to do that one section. So we got some options. I mean, I want to make sure that I answer questions. I want to make sure, because that's what we did last Tuesday, right? We took the whole time to answer questions. So I want to make sure you guys feel good about that. Any questions out of 2.1 and 2.3 or 2.2? And then if we still have some time, I can go on to a little bit of 2.4. But it's really up to you guys. I want to make sure that you guys feel okay about this stuff. Anybody got any questions out of 2.1 that y'all want to ask? Okay, so do you know which problem you're looking at in particular? From what section? 2.1? Okay, so yeah, guys, let me pull up 2.1 and we'll take a look. And so let me do this real quick. Let's go like that. Let's come back over here. Let me click on this part. Let me click on my lab. Alrighty. And let's go like this, assignments. 2, 1. And we're looking at the first problem here. And is this one you were talking about? It gives me 2 points, and it asks me to find the distance. I just can't hear you, I'm sorry. Okay, different numbers, but the problem is basically the same? Yeah. Okay, so guys, we're going to do this real quick. Let's go like this. All right. And so let me do a little copy right here. Need that. Minimize this, and let's come back over here. And I'll tell you what we'll do. Back here. Let's move that over. Okay. So guys, this is problem number 1 out of 2.1. Again, everybody's problem can be slightly different. Your numbers may be different, but the problem is in essence going to be the same, right? And it says, for the point P, which is 4, 0, and Q, which is 11, 3, find the distance PQ. Okay, so the first thing I'm going to do, y'all, I want to think about it like this. When we have the point P, every point has 2 coordinates, right? We have x coordinates and we have y coordinates. So we call them x1 and y1 and x2 and y2 just to signify there are 2 points, okay? And the distance formula says the way we find the distance is we're going to take x2 minus x1 squared plus y2 minus y1 squared, and we're going to take the square root of that whole business here, okay? So first thing I want us to do, I want you to look at the points that we have here, okay? The first question I'm going to ask you, look where x2 is. Here's x2. It's the x coordinate of the point Q. What is the x coordinate of my point Q here? 11. Oops. 11. Minus x1. What is the x coordinate of my point P? Good. y2. y2 is the y coordinate of my point Q, which in this case is, anybody know? 3. Minus, what's y1, y'all? 0. All right. And so now all we're going to do, we did our plug, let's do our chug. Okay. Anybody know what's 11 minus 4? 7 squared plus 3 minus 0? 3. All right. Anybody know what's 7 squared? 49. Good. What's 3 squared? Good. We're almost done. 49 and 9 is 58, right? Okay. So now we get to this step. And the question is that answer good enough? So usually what we say is if you can break down the square root of 58, we're going to do that. Now I know 58 is not a perfect square. I can grab my calculator, right, and go like this, turn it on, clear it, and I can go square root of 58. I don't think you guys at home can see this, but I'm just taking the square root of 58, and it comes out to something like that, right? 7-point change. And that's not what they're asking me to do. But remember what the square root means. Square root means I'm getting pairs. So can I break down 58? I know I can at least divide it by 2. And so if I take 58, let me grab my calculator again, turn it on one more time. 58, I divide it by 2. I'm coming up with 29. But I can't break down 29. 29 is one of those prime numbers. So we're just going to stop right there. That's going to be the square root of 58, right? And then what I'm going to do, y'all, is I'm going to come back to my problem right here, and it's going to ask me, what's the distance? And we said it was the square root of 58. And I'm checking my answer, and we got it, right? Oh, okay. You put the midpoint first? Yeah. So it's asked me for that, and now it's asked me for my midpoint. So let's go ahead and do our midpoint, just so that everybody has an idea how we do this. And okay, so now we're going to do our midpoint. So again, guys, remember the midpoint formula. is x1 plus x2 all over 2, and y1 plus y2 all over 2. And so if I kind of come back over here, just so we can all see again, there we go. I think everybody can see this. All right, so we said x1 and x2. So that's going to be 4 and 11 over 2, and 0 and 3 over 2. So 4 and 11 is just 15 over 2, and 0 and 3 is just 3 over 2. So that right there should be my midpoint, right? And if I come back over here, I'm sorry? I'm sorry, I can't hear you. Yeah, I don't have to actually do any division, right? Like if it would have been, say it would have been 14 over 2, I'd put 7. You know what I mean? Like if I can actually divide it out, I'll divide it out. But because the answers that we came up with were 15 and 3, like 2 doesn't go in nice and neat into 15, right? And it was accounted it right? Oh, okay, so yeah, you can probably do it that way too. So look, let me check something real quick. I'll tell you what, I'm gonna do it this way. Because it does say using integers or fractions. So the only reason I would do it with like fractions, I would go like say 15 over 2, like that. But the other one was what, 3 over 2? So if I did 1.5, let me see if that's gonna work. In this box. Oh man, it's still not doing it. You're not in the box? Let's see if that works. I think it's just the way I'm entering my answers in. Okay, let's go 15 over 2 and then 1.5. Let me see if that works. Yeah, so it'll take decimals too. That makes it easier. So if you want to write 7.5 and 1.5, that's fine. If you want to leave it as fractions, it looks like it's taking, in either case, it looks like it's taking them, which is good, right? I don't want you all to get the problems wrong because you wrote it as a decimal and it said to do it as a fraction. But, and the only thing I would tell you is like, the nice thing about dividing by 2 is either it goes in nice and neat or it's going to be a 0.5, right? But for whatever reason, guys, if in any other problem, if you ended up getting a decimal and you decided to round, so the answer was, say, 1.33 and it had a bunch of 3's, and you just put 1.3, that it'll probably count it wrong because now you're rounding. You see what I mean? So as long as if you come up with a decimal and that decimal ends, so you come up with something like 14.875, and it stops there, go ahead and write 14.875 and see if it works. But don't write something like 4.88 and say, well, that's because I decided to round. You see what I mean? So just don't do any rounding and you'll probably be okay. Good question, good question. Any other questions out of 2-1? Anything at all? You guys felt okay about 2-1? Yeah? What about 2.2? Anybody have any questions out of 2.2? Let me ask you a question, guys. Was chapter 2 easier than chapter 1? It seemed easier?
Yes.
Good, good. So no questions out of 2-1 or 2.2? I'll tell you what then. I don't want y'all to drive like. Is everybody here from the Wesco, Donna, Mid Valley area? Anybody come from any? You said you came from Raymondville, didn't you, the other day? That's where you work. But you live close by? Anybody else? Anybody not live like? Where do you come from? Harlingen. Far. Okay. So I don't want you guys to say, man, I drove all the way from Harlingen over here and I was only in class 30 minutes, or I drove all the way from far and I'm only here 30 minutes. So guys, if y'all don't have any other questions, let me do a little bit more material. Let me go over 2.4. Okay, so at least this way, when you go home to do it, you're not just sitting there by yourself, you know, watching the video on YouTube and stuff. Yes, ma'am. Yeah, definitely, definitely. Yeah. So guys, look, let's do a problem out of 2.2, just a couple of problems. And then, yeah, like I said, if we still have some time, then we'll do a little bit of 2.4. Oh, that's 2.4. You said 2.2. circles. So let's take a look at 2.2. Okay. And it says, enter the correct answer to complete the following sentence. So I tell you what I'm going to do. I'm just going to do like we did before. I'm going to do a little copy and paste. So let's go copy this. And let me copy this here. Let's see if it's copying. And then what I'm going to do, y'all, is since this problem comes out of 2.2, what I'm going to do with you guys is I'm going to put this right next door. Okay. And so let me see if. So I'm trying to make this so that you can see everything.
You're taking so long.
The monitor is just really small, but it's pretty big up here. Okay. So what we're looking at here, y'all.
Caleb, we don't have regular headphones.
The
Check to
form
see the
of an
bits.
equation of a
La
circle.
pega ahí en la
And
elliptical.
the center is the
You
point
should
that we
start
call,
right there.
or the point H case, what we call the center.
No,
and
not
R
those.
is the radius, okay?
In the elliptical
And
están
so
los de
what
los
we're going to
kids.
do
Those
is we're going to figure
like
out
the
how
whole
would
thing.
I apply this formula to the problem that I have right here, okay? So the first thing I'm going to do is I'm going to write down the center. They told me the center is the point 3 and 4, and they told me that the radius was equal to 2, okay? And so what I'm going to do now is I'm going to come back and I'm going to copy this piece down. I'm going to say, look, the form says x minus h squared plus y minus k squared equals r squared. And this is the value of h. And that part right there is the value of k. And so just like we did before, y'all, this is really, a lot of it is really plug and chug type stuff, right? So look, I'm going to write x. The next part says a minus, so let's put a minus. And then it has the point h. H in this case is the number 3 squared. And then we have y minus the number k, which in this case is 4 squared, equals, look what we have here. We don't just have the radius, we have the radius squared. So I'm going to come back over here, I'm going to put it 2 squared. And then the only thing I'm going to do now, y'all, is I am going to square that number 2. And 2 squared is 4, right? So this is problem number 1. At least this is my problem number 1. Yes, sir. The radius, but it tells me here that the radius is 2. You see what I'm saying? Okay. Yeah. And so that's all I really got to do, right? And what I'm going to do now, y'all, is I'm just going to enter what I wrote out right here by hand. I'm going to type that into my thing right here. So I'm going to do it just like we did, and I want to see if I can do. I want to see if I can do this. Just so that you guys can kind of see it, hopefully about the same time. Let me do this too. There we go. Okay, so we said X, oops, no capitals. So guys, that's one thing it will do. If you put capitals, it'll kind of wrong. It's a little picky that way, or at least it used to be. I don't know if it still is. Squared plus parentheses y minus 4. Close it off again. Squared equals, and then we put 4. So guys, notice that x minus 3 and that y minus 4, I'm not doing anything with it, right? I just plug my numbers in, but I don't need to multiply any of that stuff out. I don't need to do anything else. The only thing I wanted it to do was, instead of us writing 2 squared, let's write 4. And then I'm going to go, let's check our answer. And we got it. Seems good so far. Now I know that was problem number 1, right? But let's do this. Let's see if we can do another one again. And let's see. Let me actually get to a different problem. And let I'm just kind of scrolling through to see what problems we got here. Those two look kind of similar. These look a little similar. We'll do one of these two. And then we'll do one more. Okay, so let me come back and let's take a look at this part right here. Okay, so first thing I'm going to do here is just like we did before, let me do a little copy and paste. And so I'm going to do this number. Okay. And let me copy that. I don't need this anymore. Let's go over here. Okay. Paste it, and let's see if I can make this a little bigger. There we go. Okay. So what I want us to notice is, remember, when we're looking at the equation of the circle, it's always going to be in this form right here, right? And the one thing that I really want to mention is the center is always the point H and K, and R stands for the radius, okay? So I'm going to do the radius first because I think it's probably the easiest part. The last number is not giving me the radius. The last number is actually giving me the radius once it's been squared. So I want you all to do me a favor. That is the radius once it's been squared. So think about it for a second. What number would you have to square in your head to get 25? 5. Okay. So since they're all 25, we know that the radius for every one of those problems is going to be 5, right? So that part makes it easy because we know the radius is, it's 25 all the way across, so the radius has to be 5. Now, the way we find the center of the circle, if you notice here, there's a minus, and if you notice here, there's a minus, but the center is just the point H and K, okay, without those minuses. So when I want to find the center, say, of this circle here, what I'm going to do is whatever sign I have right here, in terms of my center, the signs are going to be changed. So if I see a -5 and a -2, it's just going to be 5 and 2. Because there's already a minus here and there's already a minus here, but those don't have minuses. So the first one, the center is at 5 and 2 and the radius is at 5. Let's do the same thing for the next 3. Remember what we said we're going to do. We're going to look at these points here and we're going to change the signs to find the center of the circle. So what's the center of this one here? What would you guys say? Remember, we're going to change these signs. 5 and -2. Excellent. And we'll do the same thing for these over here. So this center will be -5 and +2. And then for this one down here, the center will be -5 and -2, right? Okay, so just like we did before, y'all, let's see if we can do a little mix and match, right? So I know this is like, okay, so guys, I don't know if y'all had these problems where I look at this thing and it's like, man, that's, those are pretty small graphs, right? So I think you can normally do something like this. Here we go. So let's look at the center of this circle. The center's at -5 and -2, right? So what I'm going to do is I'm going to say, which was the one that had a center of -5 and -2? The last one did, right? Part 8. So when I come back to this part right here, I'm going to say that this first one here goes to number 8. So I'm going to drag this. Huh? Yeah, I'm trying to figure out why. There you go. I had it right there. Yeah. There. I missed it again. Okay, I'm gonna just go real slow here, y'all. There we go. Okay. So yeah, it takes a little while. It's a little finicky, right? Okay. Now look, let's do the same thing for the next one here, because I guess it'll let me check my answer, but I don't want to do it. It tells you I'm wrong because I haven't done all 4 parts. I don't know if it'll do that or not, but let's take a look at this one. So look at the center here. The center here is 5 and -2, right? Because the center is this point right here, so this is +5 and -2. So I'm going to come back over here. +5 and -2 was number 6, right? So I'm going to come back over here again, okay, and I want to drag this to number 6. There we go. Okay, and then we'll do this again. So look at the center here. This is a -5 and a +2, right? -5 and a +2. So which was -5 and +2? That was number 7, wasn't it? So let me come back over here, okay, and let me see if I can drag this right there, number 7. And then by process elimination, this one has to be number 5, right? It's the only one that we still got left. There we go. And then we can go, let's check our answer. And we got it. So the main thing, guys, when you're doing the circle, remember, the last number over here, the number over here all the way to your right, is always going to be the radius once you've squared it. So what you got to ask yourself is, what number do I have to square to get 25, or whatever number you have, right? And guys, I'm going to point something out. Let me try something real quick. Let me come back to, I think they might all be kind of pretty numbers. So if you look 25, what number when you square it gives you 64? 8, right? Good. I was trying to see if there was one that didn't have pretty numbers, but it looks like they all got pretty numbers, right? But in case it didn't, all you're doing is you're taking the square root of that number, right? So the square root of 25 is 5, square root of 64 is 8, that kind of stuff. Okay. And so let me see if I can do, let's try this one here, right? So it says, find the center radius form of the equation of the circle described, and then let's graph it. Okay. So let me copy and paste again. And then we'll go ahead and go on. After this, guys, we'll do a little bit of 2.4. I just want to make sure that you guys feel okay about some of that stuff there. All right, and let me do a little zoom. Here we go. Okay, so again, guys, in doing these problems, remember what it is I'm trying to do. Come on, pen. There we go. I'm looking at x minus h squared plus y minus k squared equals the radius squared, right? And it's already given me the center of my circle, and we have our radius. So remember what it is I'm going to do. I'm going to write x minus this number right here is a -1 squared plus y minus this number right here is a 0 squared equals, in this case, they gave me 2 again, so we'll stick with 2. It won't always be 2, but the problems that we came up with. Now, I'm going to simplify this piece, guys. Minus and minus, doesn't that really give me plus? Because when you subtract the negative, it becomes positive, right? And then y minus 0, that's just y squared, right? Because y minus nothing is still y, but I still got to square it. And then equals, anybody know what's 2 squared? 4, right? Okay. Remember earlier what I said about the center of our circle? Whatever number that we had right here, we had to change the sign. So if I saw a positive one there, I'm going to write a -1. And then because there's no number over here, that number is really understood to be what? 0, right? And so look, that's exactly what we originally started off with, right? Okay, so here's the center of our circle. And we said that the radius that they already told us was 2. Okay, so I'm going to fill this part in where we actually have to write it out, because it says, first thing it wants me to do, it wants me to write out the equation. So here's my equation. So let's go ahead and fill that part in. So right here, guys, I'm going to put x plus 1, and then we're going to square that. There we go. Plus y squared, because we didn't have, the y coordinate happened to be 0, right? Equals, and then it was 2 squared, which we said was 4, right? So we're going to check our answer. Boom, we got it done, right? And then now we're going to graph it, okay? So when we're going to do the graph, remember what the center was? The center was -1 and 0. So guys, when I click on this here, the one thing I don't know how many of you guys have used MyLab before or you haven't, but I think the graphing feature is actually kind of neat because they make it easy for you guys. What are we drawing here? We are drawing what? Drawing circles. Well, then I'll tell you what, click the circle button. That's one you're going to use, right? Remember what we said our center was? Center was -1 and 0. So -1 and 0, and if you look right up here at the very top in the yellow, you can see there it is, -1 and 0. I'm going to click on that. Now, remember we said our radius was? Our radius is 2. So what does that mean? It means from the center, whether you go up, down, left, or right, you're going to go 2 spaces. So let's do this. 1, 2. And that's all you got to do. And then we can hit save. And we can go check. And you got it done. Now, guys, when I did mine, I said from the middle, I went to my right. You could have gone up. You could have gone down. You could have gone to your left. You'd still end up with the same picture. Your point would be different, but the graph would still be the right graph, right? So when it did mine, it did the center, and then this point over here on the right. I could have done the center and the point 2 points down, and the graph, it still would have accepted it. Just like the way we did earlier where we put the fraction or the decimal, it doesn't really matter. You're going to get the same numbers, okay? What do you think? 2.2 seems okay? Good. Excellent. Good, good, good. All right. So, guys, I'll tell you what. Let's do a little bit of 2.4. Like I said, we still got some time, and I didn't want you guys driving all the way over here, and we haven't done. All we did was one section, and we still got some time. In 2.4, I think it's a good section for us to go through today. And like I said, guys, next Tuesday night, for the most part, guys, what we're doing, the pace of our class is pretty steady. We're not going to be doing more than 3 sections in a week. Okay, you should never have more than 3 sections in a week. At least I don't think we do. Off the top of my head, I don't think we do. So we should definitely have time to cover one section in class, right? So what I want to do now is I want to go through 2.4. Once I go through this section here, then next Tuesday, I can either do 2.5 or 2.6, but for next Tuesday, I want you guys to try to do as much of your homework for 2.3, 2.4, 2.5, whatever it is, and then I can cover, say, 2.6 next Tuesday, and then I can answer any questions. And guys, remember, your homework is going to be due on Thursday nights instead of Tuesday nights, so when you leave here, you still got 2 more days to finish up any stuff, and then this way also, when we come to class on Tuesdays, you can say, you know what, I know my homework is due in 2 days, I got stuck on these particular problems, right, so you know which ones to ask me for, okay? All right, so 2.4 is linear functions. And it says a function f is a linear function if for real numbers a and b, the function looks like this. All right, so guys, let me ask you a question. How many of y'all here took Math 100 or Math 200 or anything like that? Has any of you guys ever taken any of those courses before you took this class? Let me ask you a question. Is this your first math class at STC? Some of you know? This is your first? For those of you who it's not your first class, okay, do you remember what classes you guys had if you had another math class here at STC? You need to be or better? Okay, did anybody here ever take math 80, 85, 90, anything like that? Some of you may have taken those. Okay, and the rest of you guys, did some of you just finish high school within the last couple of years? Anybody? Last year or two? Okay, some of you may have just gotten out of high school. All right, so guys, for the most part, when we're doing linear stuff, linear functions, I'm going to zoom in a little bit because my pen's kind of writing thin. All right, and let's do this. All right. Does anybody remember this? Y equals mx plus b? Is that something that's relatively familiar? You may have seen it once or twice, maybe not. Okay, just to let you know, y equals mx plus b is the same thing as f of x equals ax plus b. The letters are different. I know instead of an f, we got a y, and instead of an m, we got an a. but the basic equation is in essence the same, okay? So in problems like this, y'all, what M refers to is the slope of the line, which in graphing terms we refer to as the rise over the run. That might be a little familiar. Maybe it is, maybe it isn't. We're going to talk about it. And then we have a point called 0 and B. This point is what we call the Y-intercept, which is also going to be always, guys, our starting point, okay? So look what it's asking me to do here. It's asking me to do a graph, okay? So what I'm going to do, guys, I'm just going to rewrite the problem. Instead of f of x, I'm going to write y, okay? X minus 4. Then what I want to do is I want to do a little stare and compare. I want to look at that, and I want to look at this part right here, okay? And the question I want to ask you, does anybody know what's my number b? So look, here's the b. What's my number b in this case? -4, right? So guys, because it has a plus b, but because we have a -4, I got to think of my number b as -4. So what that tells me is, since b is -4, my starting point is going to be the point 0 and -4. Okay, why 0, -4? Because the y-intercept is always the point 0, always 0, and then whatever the number b is. Okay, and in this case, b was -4. Now, we're going to do one more thing. We're going to figure out what is our m number. Now, look where the m number is. M is the number in front of what letter? In front of the x. My question to you, what's the number that's in front of that x, even though I don't see it? Very good. M is 1. Now, guys, when we talked about the slope, we said the slope, we're going to think about it, if we can, as a fraction. Since it's 1, I'm going to think about it as 1 over 1, okay? And this is what we call the rise, and this is what we call the run. So what I'm going to do now is, since this, let me get a pen here, this is my starting point. So the point 0 and -4. Okay, let me do this right here. All right, the point 0, -4 means when x is 0, y is -4. My starting point, you all, is always going to be on that y line, on the y-axis, okay? Because that starting point is what we call the y-intercept. It's always going to start on the y, okay? I'm never going to start over here or over here. I'm always going to start on this line. Now, from that point, this is telling me how I'm going to move now. Since it's 1 over 1, I'm going to move up 1 and over 1, up 1 and over 1, up 1 and over 1, up 1 and over 1. And you don't have to put a whole bunch of points. You can just put one more, but that's really what the slope is telling me. Here is my line. Okay? There's my graph. So look at what the directions told me to do. It said graph the linear function. We just did that. Give the domain and the range. Okay? Now, the one thing I want to mention about linear function, the domain and the range are both going to be what we call all real numbers. Everything between -infinity and +infinity. So we're going to go like this. We're going to say the domain goes from -infinity to +infinity, and so does the range. Okay. That's how I graph a linear function. All right. So, look, we got a few more to do. Let's do them. And if we got questions, you guys let me know. So let's take a look at this next one here. Same type of problem. Okay. So guys, the first thing I'm going to do, every single time I'm going to do one of these problems, this is what I'm going to write out. Okay. Zero and B, SP, my starting point. Okay. So let's see if we can do a little stare and compare. We're going to look at this guy right here, and we're going to look at this thing right here. First question, anybody know what the number b is? What do you think? -6, good. Okay, so remember, my starting point is now 0 and -6, okay? Now, excuse me, let's find the rise over the run, which is my m. Remember we said the m was? The m is the number in front of the x. What's the number in front of my x here? 1/2, perfect. Good, that's the rise over the run. Okay. All right, so remember we said this is my starting point. Guys, remember the starting point is always going to fall on that line, okay? So 0 and -6 is going to be right there, okay? Because of the one above it is 0, -5, the one below it has to be 0, -6, right? Now, look at my slope. My slope is 1/2. That means I'm going to rise up one spot and I'm going to run over 2. I'm going to rise up one spot, I'm going to run over 2. I'm going to rise over one spot, I'm going to run over 2. Here's my graph. Okay. Excuse me. Get a little bit of water real quick, y'all. All right. So now we got that part. The other thing we were being asked to find was the domain and the range. So my domain, -infinity, +infinity, and the range, -infinity, +infinity. So guys, just so that you understand, what does the domain and the range tell me? So when we drew a picture, you know, we kind of did it like this, right? We just did it by hand. And I'm going to kind of extend this picture, kind of like this, right? Because we know it goes on forever and ever and ever, right? Okay. When we did 2.3 at the beginning of class tonight, I said 2.3 refers to the x values, okay? So I want you to think about, here's my x-axis, okay? If I were to pick, say, this number, I just picked a random number. I just picked -4. It didn't have to be -4, but I definitely wanted something on the left side. Would I have to go up or down to hit my graph? It'd go down, right? Okay. Now remember, that x-axis, y'all, goes on forever and ever and ever, right? Do you agree with me that no matter where I am on the x-axis, no matter where I am, whatever point I pick, I'll either move down to hit my graph or I'll move up to hit my graph? And I could pick any number. It wouldn't matter. We could go all the way to the left. We could go all the way to the right and end up in Falfurias, and we could still go, and we'd go up and we would hit the graph, right? No matter where we would go. That's why my domain is from everything from -infinity all the way that way, all the way this way. The same thing happens to the range. Remember we talked about the range when we did 2.3, we said the range refers to the y values, right? Okay, so look, now I'm going to use the red pen. Here's my y-axis. The y-axis actually goes up and down forever and ever and ever, okay? Suppose I was somewhere up here. If I were to go to the right, eventually I'd hit my graph. And if I were to go to the right, eventually I hit my graph. And I could do that every single time, right? But if I came down here, well, now I'd have to move to the left. But no matter what point I picked on the y-axis, I would have to figure out which direction I got to move. But no matter what point I picked, I would be able to hit my graph, whether I moved to the right or the left, or if we just stayed right there. And that's why the range is from down here, from -infinity to +infinity, because no matter what number I pick on my y-axis, I can either move to the left or the right, and I would always, always, always hit my graph. And the same thing applies when we do the domain going on the x-axis, okay? That's why the domain and the range are always going to be from negative infinity to positive infinity. Okay? So now, look, let's do one more because we got one more right here. And let's see if we can do this one. Okay? So guys, just like we did before, first thing I'm going to do, y equals mx plus b. Okay? And we're going to do a little stare and compare. We're going to look at this, and we're going to look at that. Okay? First question. Anybody know what's my number b? 0. Very good. So guys, if I don't see a number, if there's not a number by itself, like a +3 or a -5 or something like that, then that just means that the number is there. It's just that the number is 0. So remember, my starting point, you guys, is always going to be 0, and then whatever b is, in this case, b happens to be 0. Okay, what about m? Remember what we call m? M is a number in front of the x. What's the number in front of my x? -2. So guys, I'm going to think about it as a fraction. -2/1, because I always want to think of that rise over run business, okay? So the problem we did before, we had a 1/2. I didn't have to think about it as a fraction because it was already a fraction to begin with. But if it's not, just think about it over 1, and now you have a fraction, okay? So just like we did before, y'all, we're going to do our starting point. My starting point is 0, 0, right there. Okay, now my slope is -2/1. Since the top number is a -2, instead of me going up 2, now we're going to go down 2, and then over to the right 1. Down 2, and over to the right 1. Down 2, and over to the right 1. There's my graph, right? Remember, my domain, my range, guys, every single time is going to be from negative infinity to positive infinity, otherwise known as all real numbers. No matter where you go on the x-axis, you should be able to go up or down, hit your graph. No matter where you go on the y-axis, you can either move to the left or to the right, and you'll hit your graph, right? Now, the other thing I want to mention, look at the slope of our line. The slope of our line, was the slope positive or negative? Negative, right? When I read a line, guys, the way I read a graph is just like the way I read a sentence. I go from the left to the right. As I'm coming from the left to the right, would you say that that line is going up or going down? Yeah, it's going down, right? Okay. What that tells me, if my slope is negative, my line should be falling down. From this way over here, it's like a slide going down. Okay. Now, look at this one over here. Our slope, guys, was a positive 1/2. As I go from the left to the right, that line is going up. Okay. So if my slope is positive, my line's coming up, like I'm walking up the stairs or a ramp. And if my slope is negative, my line is coming down. Does that make sense? So when you're doing your problems, guys, that automatically tells you, okay, you know what? My line should come down if it's negative, or my line should go up when it's positive. So that as you're graphing it, you're like, hey, you know what? Something isn't right here. I'm going down, but I had a positive slope. I did this or I did that or whatever, right? But at least you have that idea. You know which way you should be going. So like if I said, hey, let's take a trip. Let's go to Austin. Which way do we head? North, south, east, or west? Anybody know? Which way is Austin or Dallas or San Antonio? It's north, right? Okay, so we got in the car, right? I said, hey guys, I rented us a big old Hummer limo and stuff like that. And I'm like, Omar, where are you going? Bienvenidos a Mexico. I thought we were going to San Antonio. You're heading south, dude. You're going the wrong direction. Or all of a sudden, welcome to Star Cabin. You're going west, right? You're going in the wrong direction. Harlingen, so you have an idea of what your graph should look like, okay? All right. So now, let's take a look at the next one. Now, how do we find the slope of a line when we have a couple of points? Easy breezy cover girl, guys. There is a slope formula. And just like the way we did the distance formula today with 2.1 and the midpoint formula, or like the equation of the circle, here, this is very much, again, guys, a plug and chug type of process, okay? It's going to be a plug and chug type of process. So, We have 2 points. The first point has coordinates x1 and y1, and the second point has coordinates x2 and y2. So guys, all I'm going to do here, because this is my first point, I'm going to label this. That's my x1 and my y1. And that's my x2 and my y2. And then I'm going to write down my formula, which we have right here in front of us. All I'm doing is copying it down. Okay. So let's see, y2. y2 is this number, -8, minus y1, which is 4, over x2, which is 2, minus x1, which is a -3. And all I'm doing here, guys, is plug and chug, okay? The one thing I want to mention about the formula, you guys, is if you look right here in the middle, it's always a minus, okay? So sometimes people say, why did you put a minus -3? Because it's always a minus, and the fact that this number was -3 means I got to put that negative there as well. I can't say, oh, well, there's already a minus. I still got to put it, okay? So let's do this. Remember, minus and minus, guys, is going to become plus, so I'm just going to do that. Let's do this first part and make sure that we can figure out what this is. -8 minus 4. Remember what that means. I owe you $8, and I ask you, can I borrow another 4? And you lend me $4 more. How much money would I owe you now? -12, right? Good. And then 2 plus 3? There's the slope of our line. -12 over 5. Guys, let me ask you a question. We're not doing anything else. That's all we have to do. But if I was going to draw that line, would that line go up or would that line come down? It would go down because our slope is negative. Perfect, right? So you already have an idea of what the line would look like. You know, how steep is it? Because who knows? But we know that the line is going down, right? Okay, let's do the same thing here. Guys, just like we did before, I'm going to call this x1, y1. I'm going to call this one x2, y2. And guys, I'm going to write down the formula simply because I want you to see how I'm doing my plug and chug. People often ask me, okay, sir, what formulas do I have to memorize? You actually don't have to memorize any formulas. When it comes down to, say, the test, stuff like that, number one, I'm going to provide you with a formula sheet. Number two, guys, you're going to be able to access your notes, okay? So you'll be able to use your notes and all that kind of good stuff, okay? You don't have to worry about memorizing the formula. You just have to worry about how do I use it. And so the main reason why I write the formula down is now that I wrote it down, now I can figure out how do I use this thing, right? So let's take a look here. Y2. My number y2 is the number -7 because it's that one right there. Y1 minus a -3. X2 is the number 1 minus 5. Okay. So let's go ahead and fix the minus parts. So minus and minus become plus. So now let's see if we can figure out this piece. -7 plus 3. I owe you $7 and I only have 3, and you say, pay me. I give you the $3 that I have. Are we cool or do I still owe you money? How much would I owe? -4, right? Okay, now let's do the bottom piece. 1 minus 5. I have $1, but I owe you 5. And you say, pay me. And I said, well, this is all I got. I give you $1. Are we cool or do I still owe you money? How much would I owe you? There you go. Okay, last step. -4 divided by -4 is a +1. Positive, right? Because a negative divided by negative is a positive. Guys, I'm going to ask you one more question. We're already done with the problem, but I'm going to ask you one more question. If we were to draw the line that had those 2 points, would that line go up or would that line come down? It would go up because we got a +1, right? There you go. All right. So now let's take a look at the next one. And let's take a look and see if we can figure this one out. We're going to do the same exact thing we've been doing before, guys. Okay, remember, this is my x1, this is my y1, this is my x2, this is my y2, right? And let's see. So let's go ahead and write out the formula again. All right, so y2, my y2 number here is 4. My y1 number is also 4. My x2 number is 6 minus my x1 number is a -2, okay? So guys, just like we did before, first thing I'm gonna do, I'm gonna fix that minus, okay? And so let me ask you a question. What's 4 minus 4? 0, right? Okay, what about 6 plus 2? 8. Anybody know what 0 divided by 8? 0. Okay. So, guys, we've already done the problem, just like we did before, right? But I asked you a question earlier, and I was like, hey, does this line go up? Does this line go down? So remember we said, if the slope was negative, the line was coming down. And if the slope was positive, the line was going up. Is 0 positive, negative, or neither? It's neither. Okay, so we know it's not going up, and we know it's not going down. So guys, I'm going to show you guys something. You don't have to do this part. I just want you to see, what is this line going to look like? So look, let me do something like this, and like this, and like this, and like this. Okay, here's x, here's y, -2 and 4. So 1, 2, 1, 2, 3, 4. Here's the point, -2 and 4. 6 and 4. 1, 2, 3, 4, 5, 6. And 4 is right here. Okay. And if I were to draw this line, oh, I missed my point, so I'm going to go like that. Like that. I was just kidding. Okay. That's what our line looks like, right? It's not positive, so it's not coming up. It's not negative, so it's not coming down. It's just cruising like that, right? Real steady. And that's, so anytime I have a slope of 0, guys, lines like this are what we call horizontal lines. Horizontal lines always have a slope of 0 because they're not going up and down. And it doesn't matter if the line is up here or if the line would be down here. Anytime you have a line going left and right like that, that slope is always going to be 0, okay? Now, before I go on to the next part, do you remember earlier today in 2.3 when we talked about functions and is this a function or is this not a function? We had something called the vertical line test. And we said if you draw a line, if it hits it, vertical line, if it hits it more than one point, it was not a function. So I'm just going to show you guys something real quick, y'all. And again, this is just something on the side, just so that you know, okay, since we were talking a little bit about this. Okay. And I'm going to pick a couple of points. I'm going to go 1, 2, 3, 1, 2, 3, 2, 3. Okay, so let's pick this point right here. Let's say this point here is the point 2, 3. And I'm going to pick another point right here. And I'm going to say this point here is the point 2 and -1. And if I were to draw this line, that line is vertical, right? And I just picked those points, guys. The points aren't necessarily important, but I wanted to make sure that my line was vertical, right? And the reason why I'm showing you this is, remember, if I call this x1 and y1, and I call that x2 and y2, and I said, you know what? What's the slope of that line? I could say, well, you know what? Let me go ahead and see if we can figure this out. And I might say something like, look, what's my y2? Oh, that's a -1 minus 3 over 2 minus 2. So remember, what does -1 minus 3 mean? It means that I owe you $1 and I borrow 3 more. So now I owe you 4. But guys, let me ask you a question. What's 2 minus 2? 0. Okay. Guys, in math, the one thing we cannot do, we can't divide by 0. Okay, it just doesn't work. So what we say here is that this is undefined because we cannot divide by 0. Okay, it's just the one number we can't divide by. We can divide by any number, just not 0. So what does that mean? If I have a vertical line, the slope is undefined, okay? Because I don't know if that line is going up or if that line is going down, because it's vertical. It's going both up and down, and it can't be both positive and negative at the same time, because you said if it was going up, it was positive. If it was coming down, is negative. That line is going both up and down. It can't be positive, negative, so we say it's undefined, okay? So just kind of showing you that that's what happens, okay? So now let me kind of scroll back over here, and I want to show you something real quick. If you look at this part right here, guys, positive slope, hey, line goes up. Negative slope, hey, line comes down. Slope is 0, horizontal lines. And the one we just did right now, vertical lines, are undefined slopes, okay? So we just got a couple more problems to go. So let's finish up these here, and then we'll be done with 2.4. And then again, guys, next Tuesday, whatever questions you have questions out of 2.3, 2.4, 2.5, ask me. What I'll do in class is I'll cover 2.6, and then we'll go over any questions you guys might have, okay? So this problem here is just tell me, can we graph the line passing through the point and having the slope? I bet you we can, okay? So look what I'm gonna do. The first thing I'm gonna do, that's the point that was given to us, right? We didn't know the starting point. We didn't know the point on the y-axis, but we know the point -1, 3. So what does that mean? Oops. That means I'm going to come to the left 1 and up 3. And this here, guys, is now my starting point, because that's the point that they gave us. Now, we also know the slope of the line. The slope is 3/2. So what am I going to do? 1, 2, 3, 1, 2. Does that make sense? We're good so far? All right. And it's all, the only thing it's asking me to do is graph the line. So we did. We drew the line for us, right? All right. Let's do the same thing here. Look, we're going to plot this point here first. -2 and -3. So we're going to go to the left 2, and we're going to come down 3. That is my starting point, okay? Now, look at the slope that they gave us. They gave us the slope -3/4, or -3/4. This is usually my recommendation, you guys. When you have a fraction that's negative, you're going to think about the negative either with the top or with the bottom, but we're not going to think about it with both, okay? So you can decide, do you want it on the top or do you want the negative on the bottom? Right now, I'm going to put it on the top, but I'll show you what happens when we get it on the bottom. So look what this means. Since the top number is a -3, I'm going to go down 3 spaces. 1, 2, 3. Since the bottom number is a +4, 1, 2, 3, 4. And I'm going to try to draw this as pretty as I can. Something like that. Okay. And you might say, okay, well, you know what? What happens since we didn't think about it this way, but you decided to think about it like this? I say, okay, if this here, if I'm now doing a +3, I'm going to go up 1, 2, 3, 1, 2, 3, 4, and we have the same line. So which one I think about it? It's up to you. I use, every time I do a little video, guys, I always just do it on the top. But you can do it on the bottom, and you're going to get the same picture. Okay, your line is going to look the same. But if it's negative, you pick one. Do you want it upstairs? Do you want it downstairs? But we don't say both, because negative divided by negative is positive, right? All right. So now it looks like we've got a word problem. We got 2 word problems, and I think we're done with, yeah, 2 word problems, and then we're done with 2-4. So let's go ahead and see if we can figure out what this problem here is talking about. Okay, so it says modeling cost, revenue, and profit analysis. Okay, so it says a firm will break even. That means there's no profit, no loss, as long as the revenue just equals the cost. All right, the value X, which is the number of items produced and sold, where C of X equals R of X, is what we call the break-even point. It says, assume that each of the following can be expressed as a linear function. All right. So we got to find a couple of pieces here. We want to find the cost function, the revenue function, the profit function, and the break-even point. Okay, so let's do this hopefully as simple as we can. The cost function. Suppose we are making, I'm still old school, so suppose we're making headphones, okay? We're making headphones here. The variable cost tells me how much money does it cost me to make one pair of headphones? Well, it takes me $10, and I don't know how many headphones I'm going to make, so I'm letting X be the number of headphones I'm going to make. So if I wanted to make 5 headphones, 5 times 10, it would cost me $50, right? If I wanted to make 7, 10 times 7, it would cost me $70. Now, there's something called the fixed cost. The fixed cost means you're going to pay this amount whether you make 1 pair of headphones, whether you make 7 pair of headphones, or you make 108 pair of headphones. So no matter what, I got to pay $500. Think about it like that's the rent that I got to pay to rent the warehouse where I'm going to make these headphones in or something like that, okay? All right, so here's my answer for part A. Did that make sense on how I was able to explain it? Like how I came up with this thing here, how we came up with this equation? It's always going to be your variable cost times X plus the fixed cost, okay? Now, B says, let's find the revenue function. The revenue function, guys, is how much money we're going to bring in, okay? So how much are we selling every pair of headphones for? $35, right? So if I sell 1 pair of headphones, I make $35. If I sell 10 pair of headphones, I make $350. So on and so on and so forth, right? Okay, so we got that part done, okay? Now, we're going to do part C, the profit function. All right, so think about it like this, guys. Cost, how much I have to spend to make these things. Revenue is how much money I'm going to bring in. Profit is how much money I actually made, right? So it's not just the money that I brought in, but I have to subtract what I spent, right? So I'm going to take 35x minus this whole piece. And when I say this whole piece, I got to put it in parentheses, y'all, because I'm subtracting all of it. Not just the first piece, I'm subtracting that 500 as well, okay? This is going to give me my profit function. So what I'm going to do right here, you guys, I'm going to write P of x equals 35x. Now, I want you to think about this for a minute. The number here is a -1. And all I'm doing is multiplying those pieces there by -1. That becomes a minus 10x, 10, a minus 10x, and a minus 500. Okay? And so my profit function is now 35 minus 10, 25x, minus 500. Okay. All right. So we found our profit function. Boom, right here. Okay. Now we're going to do part D. Part D says we're going to find the break-even point. So if I had a profit, that means that if I made so many headphones and I sold so many headphones, I actually made money. So my profit would be a positive number, right? If I lost money, that meant that I made so many headphones, but I didn't sell enough, and so I actually lost money. Break even means I didn't make any money, I didn't lose any money, I ended up with exactly what I started off with, which was 0. So that tells me that my profit is going to be equal to 0. So what I'm going to do, guys, is I'm going to take this profit function right here, 2500 or 25x minus 500. And I'm going to say, I want my profit to be equal to 0. This is going to tell me what we call the break-even point, okay? So if I want to solve this equation here now, what I need to do, just like we did last week, guys, I'm going to take this 500 and I'm going to move it over. So when we cross the equal sign, what kind of 500 do we get? Yeah, it's negative, so it's going to become positive, right? And then we're going to divide both sides by 25, okay? And so what I'm going to do here, guys, I'm going to take my calculator, turn it on, let me clear this. I'm going to say, what's 500 divided by, say, 25? And I'm coming up with 20, okay? So what does this mean? This means that if I sell exactly 20 headphones, I don't make any money. In order for me to make money, I have to sell more than how much? More than 20, right? I have to make more, I have to make and sell more than 20 headphones in order for me to make any money at all, okay? So that's our break-even point. Now, I'm going to come back over here to make sure that we've answered our question. So look at part D. It says, find the break-even point. We did. It was 20. And then it says, and decide whether the product should be produced. Should we make these headphones given the restrictions on sales? Look what the restriction on sales is. We can't sell more than how many headphones? 18. And in order for me to make money, I have to sell more than 20. Do you think we should start making headphones? So we're going to say, don't produce them, right? Don't produce them because it tells me for whatever reason we can't sell more than 18. I don't know why, but we can't. So okay, we'll find something else to make. Okay, we won't do headphones. All right, so guys, I got one last problem here. Okay, so now let's take a look. It says modeling the break-even point. This is just like the problem we did. Okay, it says the manager of a small company that produces roof tile has determined that the cost in dollars C of X of producing X units of tile is given by, they gave us a cost equation. So in the problem before, we had to come up with the equation. They give us one here. That's nice of them. The revenue, they give us the revenue equation. The problem we did before, we had to figure it out, but they give it to us here. Look what it's asking me to do. It's asking me to find the break-even point and the cost and revenue at the break-even point. Okay. So guys, remember before the way we did the profit function? I know it's not asking me for profit, but do you remember the way we did the profit function is we took the revenue minus the cost? So that's what I'm going to do here. The revenue was 240x, 240x minus the cost, which was this whole thing, 200x plus 1,000. Okay. And then just like we did before, guys, I'm going to think of the number here being a -1. So I'm going to say this is a 240x minus 200x minus 1,000, and I'm going to set this equal to 0 because that's going to give me my break even. When we don't make any money, when we end up with exactly $0, that's my break even point. Okay. So 240 minus 200 is just a 40x, right? Minus 1,000 equals 0. So guys, just like we did before, do you remember how when we moved this 1,000, when we moved it over, what kind of 1,000 did it become? If it's negative, it's going to become, there you go. And then now what we're going to do is we're going to divide everything by 40. And again, all I'm going to do here, guys, is grab my calculator, right? So guys, the one thing I want to mention, and you know, before the pandemic hit, it had been a couple of years since I taught college algebra. I was teaching more like the math 80, 85, 90, that kind of thing, or math 100, 200. But the one thing I always mentioned when I did teach college algebra was, it doesn't really matter if the numbers are huge. That's why we got the calculator, right? So if I ask you, what's 12 divided by 3? Oh, right away you're going to say 4. But I've asked you, like, what's 1,000 divided by 40? I don't want you to worry. You said, hold on, let me go on a calculator. It's 25. I say, there you go, 25, right? So don't worry when numbers are big. That's what we got the calculator for, okay? So look, we came up with the answer. It says, find the break-even point. There's actually another part. Find the break-even point. So this part here, we're going to say x is equal to 25, okay? And then it says, let's find the cost and the revenue at the break-even point. So what that means, what they want me to do, guys, is they want me to come to this piece here and to this piece here, and everywhere we have an x, we're going to plug in what number? 25. Okay, let me ask you a question. Which equation should we use? The top one or the bottom? Which one would be easier for us to do? The bottom one, because all you got to do is multiply it by what? 240 times 25, right? So look, we're going to go like this. R of x, or actually I should say R of 25 equals 240 times 25, which is, I don't know, times 240, 6,000. Okay. Now, guys, I'm going to give you a hint. C of 25, it's also 6,000. Why? Because that's when the two functions are equal to each other. So it doesn't matter which one you do, but in terms of plugging the number in, it was a lot easier for me to just say 240 times 25 instead of saying 200 times 25 and then add another 1,000. Not like it's hard, but it was easy for me to do the bottom part, right? And we got our problems done. Okay. What do you think? Feel good today about what we did? Yeah? Thumbs up, thumbs down? Good? Okay. Yeah, it was a little bit a lot, but again, guys, I didn't want y'all to come over here and then in 30 minutes, 40 minutes you're done and like, man, I drove all the way here for this. So I wanted you guys to kind of get like the most bang for your buck, right? Like I said, I'm going to supersize you gratis, right? Okay, so guys, remember the homework for chapter 2 is due not this Thursday, but the following Thursday, right? Which is September 23rd. So when we see each other in 1 week, right? We've already done 2-4, right? We just did 2-4. Now I know you guys still might have homework and whatever, but next Tuesday, my plan is to go over section 2.6 and then answer any questions you might have. So between now and Tuesday, what I would really like for you guys to do, if you can, try to get up to as much of 2.5 done as you can. And if there's a problem you don't know how to do, just skip it. And then when you come to class next Tuesday, sir, I don't know how to do this one out of 2.3. I don't know how to do this one out of 2.2. I don't know how to do this one out of 2.5. And we'll do as much of that as we can once we're done with 2.6. Does that sound good? And then, you'll still have a couple of days because your homework isn't due till that Thursday. All right? Anywho, that is it for us tonight, guys. Thank you all for showing up. Guys, by the way, the other thing I was doing, let me see. Here we go. Is anybody here? Claudia is still here with us. Thank you, Claudia, for coming. Good. I'm glad you could hear everything. So, guys, the other thing I did here, let me